All right, today we're diving into a pattern that is absolutely essential if you're working with microservices, the Saga. Seriously, it's the key to keeping your data consistent when your entire application is split into all these independent little pieces. If you've ever scratched your head wondering how to handle complex transactions that span multiple services, you are in exactly the right place.
Okay, let me ask you this. Have you ever bought something online? You see the money leave your account, but then nothing? The order itself just fails or vanishes into thin air? It's so frustrating, right? Well, that's a classic sign of a distributed transaction failure. And that's the exact problem we are going to solve today. So here's the game plan. We're going to start by understanding the core problem, what I'm calling the distributed dilemma. Then we'll introduce the Saga pattern itself and break down its two main flavors, choreography and orchestration. We'll watch it handle a failure in real time, see how companies you use every day rely on it, and we'll wrap it all up with a super concise summary that'll make you look brilliant in your next system design interview.
All right, first things first. Before we can really appreciate why the Saga pattern is so cool, we have to dig into the problem itself. Why do these distributed systems, which are supposed to be super reliable, fail in these, well, really frustrating ways for us users?
So picture this. You're on an e-commerce site, you click buy. What happens behind the scenes? Well, it's not just one thing. First, an order has to be created. Then your payment needs to be processed. After that, the item has to be reserved in the warehouse. And finally, you get that sweet confirmation email. Now, in a modern microservices setup, every single one of these steps, it's handled by its own separate, independent service.
And right there, that's the heart of the issue. In a good old-fashioned single monolithic application, you could just wrap that whole sequence in one big atomic transaction. It's all or nothing. Either every step succeeds or the whole thing is rolled back like it never happened. But with separate microservices, each with its own database, that's impossible. There's no single database that can enforce that all or nothing rule. So if the payment service works, but the inventory service fails, you can't just magically roll back the payment. The money's already gone. That is the distributed dilemma.
And this is where our hero, the Saga pattern, walks onto the stage. It is designed specifically to bring order to this chaos and manage data consistency in these exact scenarios. So what is it really? At its core, a Saga is just a series of local transactions. Each microservice does its own little job, updates its own database, and then basically passes the baton to the next service in line. But here's the magic. The real genius is how it handles failure. If any step in that chain fails, the Saga kicks off a series of compensating transactions to explicitly undo everything that was already done. And this idea is a huge mental shift. You have to stop thinking about some magical automatic database rollback that just erases everything. Instead, we are deliberately building undo buttons for every single step. We're not reversing time, we are actively running new transactions whose only job is to reverse the previous ones. Okay, so we get what it is, a sequence of steps with undo logic. Now let's talk about the how. How do these services actually talk to each other and coordinate this whole thing? Well, that brings us to the two main ways you can build a Saga. Yeah, the dance analogy is perfect. With choreography, all the dancers know the routine. They just listen to the music and react to each other's moves. But with orchestration, you've got a conductor, front and center, telling everyone exactly what to do and when. Let's break down choreography. With this one, there's no central boss. The order service creates an order and basically just yells into a crowded room, "Hey, I just made an order," by publishing an event. The payment service, which was listening for exactly that kind of announcement, hears it, does its thing, and then yells out, "Payment's done!" And the inventory service hears that, and so on. It's like a domino effect. Now, the big win here is that your services are super loosely coupled. The order service has no idea the payment service even exists, which is awesome for keeping things simple, especially for short workflows. But, and this is a big but, it can be a nightmare to figure out what's going on. If something breaks in a long chain, good luck tracing it back. There's no single place to see the big picture. So the other way to do it is orchestration. Here, we bring in a central conductor, a manager called the orchestrator. This thing is the brain of the whole operation. It doesn't wait for events. It sends out direct commands. Hey, order service, create an order. It waits for the okay, then it says, all right, payment service, you're up, take the payment. It manages the entire flow, step by step. And the beauty of this is clarity. Oh my gosh, it's so much clearer. The whole business process lives in one spot. You can easily see what's happening and handle errors centrally.
The downside? Well, that orchestrator can become a single point of failure, and your services are a little more tied to it, so you lose some of that pure decoupling.
Okay, we've thrown this term compensating transactions around a lot, but what does it actually look like when things go wrong? Let's walk through a failure in an orchestrated saga. This is where you'll really see the power of this pattern.
All right, let's follow along. The order gets created, check. The payment is taken, check. But now look, the orchestrator tells the inventory service to reserve the stock and bam, failure. Maybe the item literally just sold out. Now what does the orchestrator do? It stops everything. It doesn't move forward. Instead, it starts working backward. First, it sends a command to the payment service, execute your compensatory transaction, which means issue a refund. Once that's successful, it goes to the order service and says, now you cancel the order. And boom, the end result? The saga is gracefully rolled back. The system is consistent again, almost as if the whole thing never happened.
So, let's put these two side by side one more time. Choreography, it's decentralized, uses events, and it's perfect for simple flows. Orchestration, that's your centralized command-driven approach, built for more complex stuff where you really need to know what's going on. A pretty good rule of thumb is, if you've got maybe 2 or 3 services in your transaction, choreography is probably fine. But once you hit 4, 5, or more, that complexity usually means it's time to bring in an orchestrator.
Now, this isn't just some abstract textbook pattern. This is running the world. It's the engine behind some of the biggest apps you use every single day.
I mean, look at this list. Amazon? They're using it to manage that whole crazy process of ordering, paying, warehouse logistics, shipping. It's a massive saga. Your food delivery app? Yep, that's a saga too. From you placing the order, to the restaurants accepting it, to a driver getting assigned. Let's actually zoom in on one of these. Yeah, let's take Uber. Every time you request a ride, you're kicking off a saga. First, a driver matching service has to find a driver near you. If that works, the next step is the payment service pre-authorizing your card. If that goes through, a notification service confirms the ride for both you and the driver. And if any of those steps fail, like maybe there are no drivers available or your card gets declined, the saga immediately starts running its compensating actions to cancel the whole request and clean everything up.
So when should you actually reach for the saga pattern? Here's the bottom line. Use it when you need to coordinate actions across different microservices, and, this is key, your business can handle what we call eventual consistency. What that means is, for a very short time, the system might be in a weird state, like the payment is taken, but a second later the inventory check fails. The saga guarantees it will all get cleaned up and become consistent eventually, but not instantly. Now, if you need absolute, immediate, all-or-nothing consistency, like a critical bank transfer, Saga is not your tool. And of course, if you just have one big monolithic app, dude, just use a regular database transaction. Don't overcomplicate it.
All right, let's wrap this all up into a nice, clean summary that you can pull out in your next system design interview.
So you're in that interview, and they ask you about distributed transactions. Here's your answer. You can say something just like this. The Saga pattern manages distributed transactions by using a sequence of local transactions and compensating actions to handle failures. It's typically implemented in one of 2 ways, either with an event-driven choreography or a command-driven central orchestrator. That right there, that hits all the key points.
Okay, let's just nail down the 5 most important things to remember. 1. Sagas are for managing long-running transactions in microservices. 2. They give you eventual consistency, not strict, immediate atomicity. That's a huge one. 3 and 4. You can build them with decentralized choreography or centralized orchestration. And finally, number 5. The magic undo button is the compensating transaction.
And that leaves us with a final question to chew on. We know the pattern guarantees that your system will become consistent eventually. But when is eventually just not good enough? What business processes are so critical they demand that instant, stripped consistency that a Saga can't provide? Something to think about. Hey, thanks so much for watching, and I'll